Welcome to qnawire.
So now we'll work on problem 26 from chapter 20. In this problem, we're asked to complete and balance the following equations and identify the oxidizing and reducing agents. So we can start with part A, where we have NO2 reacting with bichromate in acidic solution. So the best way to approach these problems is to first identify the reduction and oxidation half reactions, and then work from there. So for part A, our reduction is occurring at this bichromate because we can see that the chromium on the left side has an oxidation state of +6, and on the right side it's +3, so it's being oxidized. So we have bichromate Cr2O7, 2-, and we're in acidic solution, so we know we're going to react with protons and with electrons to produce 2 chromium because of the reaction and water. So now we can balance the equation. So we know that we have 7 oxygen over here, so we need to have 7 waters over here. And since we have 14 hydrogen over here, we need to have 14 hydrogens over here. And we have 2 chromiums going from +6 to +3, so a total of 6 electrons are transferred. Now we can work on the oxidation half reaction, which is nitrite going to nitrate. So we have NO2 minus plus H2O. In this case, it's not enough to react simply with the hydrogen protons because the protons will not react with these nitrate or nitrate molecules because they would form the acids, which would just ionize again. And also we need an additional source of oxygen to add the oxygen to go from nitrite to nitrate. So in this reaction, nitrogen is going from an oxidation number of +3 to an oxidation number of +5. So we have a transfer of 2 electrons, and we also have 2 protons. So to add these reactions up, we need to multiply the bottom reaction, the oxidation reaction, times 3. And then we can go ahead and add this up. We get Cr2O7 2- plus 14 protons plus 3 NO2-. Our water will cancel with this water here, so we don't have any water here, and our electrons cancel. Then we get 2 chromium 3 plus 4 waters, 3 NO3s, and so we actually have less than 14 protons because we have 6 protons coming from this reaction, and now we'll subtract from the 14 to give 8. Protons here. Now the question asks us to identify the oxidation and reduction agents. And so we know chromium, this bichromate compound is being reduced, so it means it's the oxidizing agent. And this nitrite is being oxidized, so it is the reducing agent. In part B, the reaction which we're given is between sulfur and nitric acid in acidic solution. So first we have nitric acid, HNO3, as our reduction reaction. And it's in acidic media, so we have H+, and this is the reduction, so we have an electron as the reactant. And we're going to N2O plus water. So if we're not sure about the oxidation numbers, we can see that this nitrogen here is losing a lot of oxygen. So it makes sense that it's reduced as opposed to oxidized. So now we can balance this equation. We need to go from this nitrogen on the left here, nitrogen on the left will have the oxidation number we can figure out. So the ion that it's a part of is NO3 minus. So NO3 minus with 3 additional oxygen. With 3 oxygen, we have a charge of -6. So this charge over here will be +5. Over here, we have a charge of +1. And so this is happening for 2 electrons. So that means we have a total of 2 atoms. So we have a total of 8 electrons being transferred here. And since we need to keep a charge neutral, that means there should be 8 protons as well. And we need to put 2 here so we can have 2 nitrogens on this side. So now in order to balance the number of oxygen, we put a 5 here, so we have 6 oxygen on this side, 6 oxygen on this side, and we have 10 hydrogen on both sides. Now we can do the oxidation reaction, where we have sulfur plus water producing this H2SO3 and protons and electrons because it's the oxidation reaction. So now just to figure out how many electrons we're going to need, over here we have 0 as the charge or oxidation number for sulfur. On the right side, we have SO3 2-, which means that the oxygen will be -6. So sulfur should have an oxidation number of 4. So we have the transfer of 4 electrons, which means there should be 4 protons on the right to balance the charge, which means that we need to add a subscript of 3 for the water on the left side. So now we can add up the reactions. We need to multiply this reaction times 2 so the electrons will cancel out. So we have 2H NO3 plus 8 protons, actually not 8 protons. The protons here will cancel out completely. Plus 2 sulfur plus H2O produces 2 H2SO3 plus 4 N2O. So the oxidizing agent here is the reaction the reactant which involves the reduction, so that's HNO3. This nitrogen here will be our oxidizing agent, and that leaves the sulfur to be the reducing agent. So now we can move on to part C, where we have the bichromate anion reacting with methanol to form formic acid and chromium 3+ in acidic solution. So first, our oxidation reaction will be the methanol to formic acid. The reduction reaction would be bichromate to the chromium 3. So we can split those two half reactions up right now. So we have this bichromate Cr2O7 2- plus protons plus electrons, producing chromium 3+ and water. So we know right away that there should be 2 chromiums on the right because we have the 2 chromiums on the left. Now we need to check and see how many electrons are being transferred here. So we're going from chromium 6 on the left to chromium 3 on the right. So that means for 2 chromium atoms, 6 electrons will need to be transferred, which means that to maintain the charge on both sides of the reaction, we'll need to have 14 protons, which means that we're going to have 7 waters remaining. For the oxidation reaction, we have this methanol, CH3OH, reacting with water, being oxidized to form HCOOH, or formic acid, plus protons and electrons. So here we have the oxygen, or the carbon, to balance this reaction. We see that there are 6 hydrogens on the left, so we need 6 hydrogens on the right. We have 2 already, so that means we need 4 protons. And to neutralize this charge, we need 4 electrons. So here, we can add up these reactions. Since we have 6 and 4 electrons respectively, we can multiply by 2 and by 3, so we can have 12 electrons being transferred total, and we can have them cancel out. So we get 2 Cr2O7 2-, and then we have 3 methanol, CH3OH. Now if we look at our protons, we have 28 protons on top, 12 on the bottom, so when we subtract, we get 16 H+. We have 4 chromium 3, 3 HCOOH, and if we subtract 14 waters from 3 waters, we get 11 H2O. So our oxidizing agent in this case is this agent, this species that's being reduced, the bichromate, and the reducing agent is the methanol. So now we can move on to part D, where we have a reaction between a bromate ion and dinitrogen N2H4. So this bromate will be reduced to bromide. We see the loss of the oxygens there, so we can do that that half reaction first. And we're in acidic medium, so we're going to react with H plus and electrons to produce Br minus and water. So on the left side, our bromine has an oxidation number of positive 5. Should be positive 5 on the right, and on the left it's negative 1, so that means 6 electrons are added to this bromine, which means that we have 6 protons and 3 waters. Now we can do our oxidation reaction, which is N2H4. Reacting to produce N2 protons and electrons. So we can see that this is being oxidized. We have N2 with an oxidation number of -2 going to 0. And for 2 nitrogen atoms, that means we should have 4 electrons here, and we should have 4 protons. So to have these add up, we have 6 and 4 again, so we multiply times 2 and times 3 to have 12 total electrons. And so we get 2BrO3 minus plus 3N2H4. Now the protons will cancel as well as the electrons, so we don't have protons. We have 2Br minus plus 3N2 and 6H2O. Now our oxidizing agent is the species being reduced, which is this bromate. So this is oxidizing agent. And then the nitrogen from the N2H4 will be our reducing agent. So now we can move on to part E, where the reaction is between nitrite and aluminum to produce ammonium NH4+ and the aluminum oxide anion. So we can see easily that aluminum is being oxidized. So we can work on the reduction reaction first with nitrite to ammonium. So we have NO2 minus, and also we're in basic solution this time, so we're going to be reacting with OH instead of protons. And we're also reacting with electrons since it's the reduction half reaction. And we produce ammonium, and because of the need to reduce this here, we're producing the oxygen anion, O2 2 minus. So here what we have is first, to balance the reaction, we see that we're going to need 4 hydrogens on the right, so we put in 4 hydroxides, which means that there's now 4 plus 2, 6 oxygen molecules. This is not O2, it's just O2 minus 2. So we should have 6 oxygens on the left, on the right, And to neutralize the reaction, or to make the charges equal on both sides, we need to add 6 electrons. That makes 6, 10, 11 negative charges on the left, and on the right we have 11 negative charges as well. So if we do the oxidation reaction, it's aluminum, again reacting with hydroxide to produce aluminum oxide plus protons plus these electrons. Now the aluminum here is going from an oxidation state of 0 to positive 3. So we have 3 electrons. We have to neutralize, that means we're going to have 2 oxygens on the left, and we're going to need to have 2 protons to balance the hydrogens. So here, to make the electrons cancel out, we just need to multiply the bottom reaction times 2. And then when we add them up, we get NO2 minus plus 2 aluminum plus 8 hydroxide, producing NH4 plus ammonium plus 2 AlO2 minus these hydrogens here, which are produced here, will react with the water that we have, the oxygen that we have here, to produce water. So 2 of these hydrogens are used to make 2 waters, and the rest of the oxygen is left as the anion. So that's the reaction, and now the reducing agent will be the aluminum, because it's being oxidized. And the oxidizing agent will be NO2, because it's being reduced. So in part F, we have H2O2, hydrogen peroxide, plus ClO2, chlorate, producing ClO2 minus and O2 in basic solution. So our reduction reaction pretty apparently will involve this ClO2 going to ClO2 minus, since it's the same molecule, simply with an addition of a negative charge. So we can see the electron being added. So we have ClO2 plus electrons will produce ClO2 minus, and that is the reaction there finished, since there's no additional atoms. Then we have H2O2, hydrogen peroxide, reacting with hydroxide, since we're in basic media. And this will produce molecular oxygen, water, and electrons. We have 2 oxygens going from +1 to 0, so we're adding, we have the oxygen going from -1 to 0, so we're taking away 2 electrons. We have 2 hydrogens on the left, 4 hydrogens on the left, so we need 4 on the right, so we have 2 waters, and we need 2 hydroxides. So we need to multiply the top reaction times 2, so the electrons will cancel out. We get 2 ClO2 plus H2O2 plus 2 hydroxide, producing ClO2 minus times 2 oxygen and 2 waters. our reducing agent is the H2O2 because it's being oxidized, and it's reducing ClO2, which is the oxidizing agent.